Here is a one-sample t-test recap. First, we learned when to use the one-sample t-test. Then, what are the t-distributions? Third, how to conduct a one-sample t-test. So far, we have learned two tests, one-sample t-test and one-sample z-test. Let's have a review session on this. So here are the 4 questions. First, how to tell if it is a one-sample z-test or one-sample t-test. Second, what are t-distributions? Third, how to conduct a one-sample t-test. And fourth, when to reject the null hypothesis. Here are the conditions when we need to use one-sample z-test. When the population mean, mu, and the standard deviation are known, we use one-sample z-test to compare a single sample mean to the known population mean of mu. The key is to look for population standard deviation sigma. If the standard deviation is given, then we use one-sample z-test. On the other hand, the condition to use one-sample t-test is that when the population standard deviation sigma is unknown, we use one-sample t-test to compare a single sample mean to the known population mean. We use the sample standard deviation S to estimate the standard error. Therefore, the key is to look for population standard deviation sigma. If it is not given, then we use one-sample t-test. Okay. Now, let's look at the in-class exercise 2. Work on question 1 and question 2. Form the hypothesis. The first question is, for population IQ score, mu is 100 and sigma is 15. Suppose you teach a group of 16 children who seem below average to you. The mean IQ score for your students is 97. You want to test their IQs to determine whether they are actually below average. Is this a one-sample t-test or one-sample z-test? It is one-sample z-test, and the research hypothesis is mu less than 100, and the null hypothesis is mu greater or equal to 100. Here is the second question. Are engineer students less extroverted than typical college student? A sample of 225 engineering majors is giving a standard introversion-extroversion scale, with higher score means more extrovert. This sample has an average of 36.5 and a standard deviation of 15.4. The mean score for general population of college students is 50, using alpha of 0.05 to test your hypothesis. So the research hypothesis is the average score of engineer students is less than 50 because 50 is the extrovert score for the general population. Then the null hypothesis is mu greater or equal to 50. Now let's look at the population college students. Suppose the mean for the college students is 50. Then if we take a sample of 225 from this population and we compute the sample mean, then the extrovert score should be close to 50. If we draw many of the samples, each sample has 225 students, then we can construct the distribution of sample means. The mean of this distribution is 50, and we don't know the standard error of this distribution, because to compute the standard error, we need to know the population standard deviation. However, this question, sigma is not given. So it is a one-sample t-test. Our solution is to use our sample standard deviation to estimate the population standard deviation. So the sample standard deviation, here we don't know like what shape this distribution is. The sample standard deviation is 15.4. So we simply use 15.4 to estimate sigma. Therefore, we compute the estimated standard error using 15.4 divided by square root of 225, which is 1.03. So when we talk about a t-distribution, we are talking about a set of distributions. When our sample size is greater than 100, then the t-distribution is approximately a normal distribution. And for our population, the mean is 50, and the standard error is 1.03. Therefore, we can look at the table to find out the t-critical score. Remember, our t-distribution is sample size specific. When sample size is less than 100, for example, this green distribution, sample size is 70 and the DF is 69. So it is wider than the normal distribution. When sample size is smaller, such as this brown one, sample size is 9, DF is 88, it is wider than the green distribution. So now we have a big sample size. So we can look at the t-distribution table and find out the t-critical score. Because we hypothesized that engineer students is less extroverted than the general population. Therefore, the research hypothesis is mu is less than 50. We look at the left tail. So the t-critical score should be negative. Now look at the t-distribution table. Sample size is greater than 100. We look at the last row. So it is DF is 225 minus 1, which is 224. Then it is one-tailed test. We look at the 0.05 here. Therefore, the t-critical score is 1.645, and it is negative. Do you remember for one-tailed z-test, when alpha is 0.05, the z-critical score was also 1.645. So it means they're very similar, literally the same. Now let's look at how to determine if it is a one-tailed or two-tailed test. The key is to look at the research hypothesis. In our example, mu is less than 50. That is our research hypothesis. So next, we need to draw the distribution. Okay. So if it's this distribution, then it is a one-tailed test. The mean is 50. We hypothesize mu engineer is less than 50. So we look at the left tail. Then alpha is 0.05. P-value should all locate at the left tail. The rejection region is this blue area at the left tail. Here alpha is 0.05. Sometimes people use a more strict alpha. It's 0.01. Therefore, the right line presents when alpha is 0.01, the rejection region is smaller. That is, if a sample mean falls in this red area, the probability of having such a sample is less than 0.01. So that is one-tailed test. How to determine if it is a two-tailed test? Again, we should look at the alternative or research hypothesis. If it is mu does not equal to something, mu is different from the population mean of 3, for example, then we draw the distribution. If the center of the distribution is 3, then according to the research hypothesis, mean does not equal to 3. So it could be greater than 3, it could be less than 3. We should look at both tails. And the alpha of 0.05 split into the two tails. At each of the tail, P is 0.025, that is half of 0.05. Any sample falls in any of these blue rejection region, we should reject the null. Sometimes we use alpha of 0.01 if it is a two-tail test. Again, 0.01 split into two tails. At each tail, P is 0.005. So for two-tailed test, you have two critical scores. One is positive, one is negative, and you have two rejection regions. One at the right tail, one at the left tail. If your score is greater than the positive critical score on the right, then you reject null. If your t statistic is less than the negative critical score on the left tail, then you also reject the null. Now let's continue our in-class question 2. T critical score is negative 1.65. Next, we need to compute the T observed score, which is 36.5 minus 50 divided by a standard error of 1.03, which is negative 13.11. So we reject null. Engineer students were significantly less extroverted than general college students. To recap our review on one sample z-test and one sample t-test, first we summarized how to tell if it is a one sample z-test or one sample t-test. Second, we reviewed how to determine if it is a one-tailed or two-tailed test. Then what is a t-distribution, how to conduct a one sample t-test, and when to reject the null hypothesis.